In this video, I want to try to implement something that I think could be called intensity scaling. So some images, they don't use the full range of intensities that are possible. Like maybe it's like a very bright image or a very dark image. And in those cases, it can be very useful to be able to rescale the intensity. So we're going to try to implement that. And to begin with, we can just make a test button and try to do some stuff in here. So we let's say that we also get the image. So image, and this button is clicked. It should be equals, and here we can borrow it. So now we have the image, and we kind of want to loop over it. And let's say that to begin with, we'll just make it darker. So we'll loop over it, and if the intensity is, and we'll kind of lower the intensity or the lightness value, how bright the image is, at every pixel. Okay, so let's try to do that. And let's define like an artificial floor. So we call it value floor, because light, like how bright something is it's called brightness, it's called lightness, but I like the value. Sometimes it's called value. So let's say everything at 0.5 or below on a scale that goes from 0 to 1, we're gonna put that to 0. We're gonna just set it to 0. So I think let's start by making a copy. Let's make a copy of the image, and it can be mutable. So we can just clone it. And then we want to loop through each pixel. So we usually do like this. And actually we want to convert this to something. So maybe we don't need the clone actually. Let's just convert it to an RGB with floating point numbers. So we already have it going from 0 to 1. So now we have the copy, and we can say enumerate pixels mutably. Okay, so the first thing is that this pixel thing is an RGB, which means that, as you can see here, it's kind of an array of 3 floats. Of course, that's RGB. RGB is equal to p.0. But we don't, to do this kind of brightness manipulation, we don't want to work in RGB space. We really want to work in HSV space. So let's write a function that converts RGB to HSV. Okay, so we can write it like this. I don't think that's particularly interesting, so I'm going to do it off screen. But you can just look up on Wikipedia the formulas, and you can also check out the source code later. All right, I will be right back. All right, so I've implemented this function, and it's in the color module. And now we can get the hue, saturation, and value. And then the point was, if the value is lower than or equal to 0.5, we set it to 0. So we can do it this way. We can say value is equal to value minus value 4. And if it's, we'll take a max with 0, such that if we end up below 0, we just set it to 0. And then we can say RGB is color HSV to RGB. And here we'll have the hue, saturation, and the new value. And that should work. And finally, we can say assign that to P. So I think that should work. Let's, and it doesn't like this, which is actually fine. We're not really using it. So let's say is sum. And then here we can just say self that image. It's ref probably unwrap, and let us try to run that. All right, so at least it compiled. And now we can try to run the function. And nothing happened. And of course, nothing happened because we're just assigning to this copy. So what we actually need to do is we need to say self image, replace it with the copy, load the color image, load the texture using the context. And that didn't work out. And this is because this is not a dynamic image, so we have to say take this thing and make it a dynamic image. Now, let's see. Okay, so it seems like it worked. We would also kind of want to do something else, like instead of a floor, what if we had a value ceiling, let's say 7.5. And here we actually want to say that if you're at 7.5 or above, then you are set equal to 1. So instead of this, we can say +1 minus, I think, value ceiling, such that if you're at the value ceiling, you become 1. And if you are above, of course, you become greater than 1. So if we do it like this, it should work. Let's try that just to see if it works. So that also seems to work. Great. But it's not so nice just to have some hard-coded values. So what we would like are some sliders. So I think we can say, is it UI slider? Is that a thing? Or we do add egui slider. So I think it's like this. But the slider requires, well, okay. Anyway, new. So let us do like this. The slider requires 2 arguments, something that's a number and a range. So we need to go up and modify the app to have, like, let's say value floor and also value ceiling. And by default, those should be 0 and 1. And here we can say, okay, we just take immutable reference to self.value floor, let's say. And the range of possible values is, of course, 0 to 1. So I don't think we need the parentheses here. Okay, arguments to this function are incorrect. Okay, it has to be an inclusive range. So we do it like this. And here now we can just say if you click the button, then we are going to do all of this stuff, but let's use the value floor now, but we use the current value of the value floor. So let's see how that works. So we have the slider here. If I do it now, nothing happens. If I turn it up a little bit, it should become a little bit darker, and so on. And you can see also a problem now. We are modifying an image. So every time we run it, it will just become darker and darker. So what we really want is actually 2 copies of this. We want like the original image and the one that's used for displaying. And that means when we load the image, which is here, load the image, we actually want to say self.original image is self.image. It's a copy of that. So we always keep the original, and when we do this thing, we want to say the original image. Okay, and then we can probably do original image here. And now every time we run it, it should just modify, I should copy the original image and run some operation on that. Now if I run multiple times, nothing happens, and we can kind of dynamically change this thing. All right. And the last thing we need to do is to go into the structs. No, we already did that. So let's add another slider, and maybe we want to do UI horizontal here, and just wrap that, the horizontal, and go ahead and say ceiling. And this one is kind of interesting. I think we can do this. That would be kind of cool. And now we actually want to do something here. Maybe we just add them. Do you think we can do that? So what happens if this is 1? And that doesn't do anything. If this is 0, that doesn't do anything. If they are equal, and then we also need minimum 1. And there's like a clamp function, so we should probably do that instead. Value is equal to, oh, let me just do it here. So clamp to go between 0 and 1. Okay, so does this actually work? I don't think so. I think we have to do it in stages actually. Just do v minus self.value floor. Okay, like this. Then plus 1 minus self.value ceiling. And that whole thing should be not more than 1. I think this is actually more likely to be correct. Let's try to run it. And we have the 2 sliders here. I can say, okay, like that. And nothing. Nothing happened at first. That was a bit weird. And it has a kind of weird behavior when I do this. So I'm gonna remove that and let's say 0, 2. No, that was not it. That was this one. 1. Run it. Say it like that. Like that. What if we have them really close? And what if we do this? That also works, but it's kind of really doing some weird things to the image. All right. What happens, by the way, if we do this and then we run the filter? That's kind of, doesn't really change anything. Run it again. Okay. I don't know. Anyway, also, why did that take so long to run? Let's see here in compute. We don't have any sleep or anything now. Okay. All right. I think that's gonna do it for this video. So I will see you in the next one.